Okay, in this video we're going to go ahead and we're going to solve the purple one here. And this guy has a little bit of a trick to it because what's different than the previous example that we just saw is that we have sine and cosine in the same equation, and they're kind of mixed up. Kind of looks like a quadratic like the other one. However, it's not, because we have two different things going on. So that means is that we need to go ahead and do a switch first thing. So what we want to do is that since this guy's squared, it might be easiest for us to go ahead and use the fact that we got sine squared plus cosine squared equals 1, and therefore we can say that sine squared equals 1 minus cosine squared. And then we can put that in for this guy, and now have everything in terms of cosine. So therefore, let's do that out and see where this takes us. So we got 1 minus cosine squared x plus 3 cosine x minus 3. And using the distributive property and just kind of rearranging this entire thing, we can do some of this in our head here, is that we're going to get a negative 2 cosine x, so we're going to get a positive 2 and this negative 3 here, so that's going to give me a negative 1 at the end. So I would have 3 cosine x and then a minus 1 equals 0. Okay, so one of the tricks when you're factoring something that looks like a quadratic, which is the same as this guy that we just did, is that I don't like that negative in front. Makes factoring sometimes, I don't know, I make careless errors with it. So what I do, and this is a legal move, is to just multiply the whole thing by a negative 1. And that way, that's going to flip all the signs, and we're going to have something a little bit easier to work with, at least in my opinion. If you don't mind the negative, then kudos to you, and it'll work out the exact same way. Okay. Now, this only works when it's all set up and equal to 0 or another thing. You can multiply through by a negative 1 to switch the signs, and nothing else. If it were equal to y and it were like a function or an equation that you're graphing, wouldn't work out so nicely, so don't do that. So now we're going to go ahead and we imagine that this guy, and I'm just going to make the t substitution, that this is going to be 2t squared minus 3t plus 1 equals 0. And so now I can just use some armchair mathematics, and I can say that this is going to be 2t and a t right here, and it looks like these both going to have to be negative and then equal to 0. So just checking our work real quick in our head, and it looks like we got it. So it appears now I have 2 cosine x minus 1 times cosine of x minus 1 equals 0. So we're back to this exercise where we're trying to get the angles that are going to satisfy these things once we go ahead and do them out in one turn around the circle. So after we set these equal to 0, I'm going to get 2 whatever the heck I just wrote. 2 cosine x minus 1 equals 0. And cosine, again, using the zero product property, that's why we factored it so we can use it out. And so therefore I would have cosine of x equals 1/2, and cosine of x equals 1. Okay, so we're looking for the angles, one turn around the circle here, that are going to, again, satisfy this. So we think, all right, all students take calculus, where are these angles hiding? So we're taking the cosine of some angle x, so we know it has to be positive, so that this first one has to be hiding in the first quadrant and the fourth quadrant. So it looks like the first occurrence is going to be pi over 3, which is going to be the 30 degrees. Take the cosine of 30 degrees, you get positive 1/2. That's also going to happen way down over here. So we got this angle, and then this one coming way around here. And that is going to be 5 pi over 3. And it looks like anything else will go any further will be out of that range that we're looking for. So our first parts of the answers are going to be x equals pi over 3, comma, let's see, 5 pi over 3. And now we just need to go fetch where cosine equals 0. Now we got to be tricky here because you notice that, and if you look in the upper right-hand corner, what I'm writing here is that this includes 0 and this does not include 2 pi, so you can't double up on it. So therefore, the only time that in this particular interval that the cosine of some angle is going to equal 1 is going to be at 0 radians, not 2 pi. Well, at 2 pi it does, but it will be out of the particular interval that we're looking for. And so that would be our final solution here. So it looks like those are the only 3 angles that satisfy our equation, and that's that. So that's how you do that, and thank you for watching.